Welcome to SS2 Technical Drawing, Term 2, Week 2. Today we develop the surface of cones. The development of a cone is quite different from that of a prism or cylinder, because the cone has a curved surface that narrows to a point. When we unfold the lateral surface of a right circular cone, it forms a sector of a circle, a pie-slice shape. This sector has a radius equal to the slant height of the cone and an arc length equal to the circumference of the cone's base. Understanding cone development is essential for making funnels, bucket molds, lampshades, conical hoppers, and megaphones. WAEC technical drawing examinations test both the development of complete cones and the development of truncated cones, cones with the tip cut off, forming a frustum. Let us begin with the complete right circular cone. The cone has a base radius r and a slant height L, which is the length from the apex to any point on the base circle, measured along the surface. The slant height L is found using Pythagoras. L equals the square root of the height squared plus the radius squared. When we unroll the lateral surface of the cone, we get a flat sector. The sector has a radius equal to the slant height L. The arc length of the sector equals the circumference of the base circle, which is 2 pi r. The angle of the sector is found from the formula. Sector angle in degrees equals 360 degrees times the base radius divided by the slant height. Example, a cone with base radius 40 mm and height 60 mm, slant height L equals the square root of 60 squared plus 40 squared, which is the square root of 3600 plus 1600, giving the square root of 5200, approximately 72.1 mm. Sector angle equals 360 times 40 divided by 72.1, which equals approximately 200 degrees. We draw this sector, a circle of radius 72.1 mm, with a sector angle of 200 degrees marked out. The two straight edges of the sector are the seam of the cone where the metal is joined. The curved arc of the sector is the base circle when rolled up. To complete the development, we add a circle of radius 40 mm to represent the base of the cone. A truncated cone, more precisely called a frustum, has had its apex removed by a cut parallel to the base. The frustum has a large base radius r and a small top radius r. To develop the frustum, we must first find the apex of the complete cone, the point from which the frustum was cut. If the frustum has base radius r, top radius r, and height h, the apex lies at a distance L from the base along the slant. Using similar triangles, the full slant height from apex to base is L equals r times L divided by r minus r, where L is the slant height of the frustum, which equals the square root of h squared plus r minus r squared. The slant height to the top of the frustum from the apex is L minus L. To draw the development, draw the full sector for the complete cone with radius L and sector angle 360 r/L degrees. Then within this sector, draw a smaller arc at radius L minus L from the apex. The frustum development is the area between the two arcs. To add the base and top circles, attach a circle of radius r at the outer arc and a circle of radius r at the inner arc. In practice, the full cone apex may not need to be drawn. Instead, draw the outer arc, radius L, then the inner arc, radius L minus L, using the same sector angle for both. The frustum development is the annular sector between them. The most challenging cone development question involves an oblique cut, the cone cut by a plane inclined to its base, giving an elliptical section. For this case, we can no longer use the simple sector method, because the top edge of the development is no longer a simple arc. We must use the generator method. Step 1. Draw the front view and plan view of the truncated cone. In the plan view, divide the base circle into 12 equal parts and number them. Step 2. From the apex, draw generators to each of the 12 numbered base points. In the front view, these generators radiate from the apex to the base circle. Step 3. Find where the cutting plane crosses each generator in the front view. Mark these points. Step 4. Measure the true length of each generator from apex to the intersection point with the cutting plane. For generators that appear in their true length in the front view or those on the front and back of the cone, the true length is read directly. For others, the true length must be found by rotating the generator onto the front view. This is called the true length diagram. Step 5. Draw the sector for the complete cone. Along each generator in the sector, mark off the true length from apex to the cutting plane intersection. Step 6. Join these 12 marked points with a smooth curve. This is the top edge of the development. It is not a simple arc, but a curve corresponding to the elliptical cut. This type of development is examined at the advanced level of WAEC and requires thorough practice. Cone developments are used extensively in Nigerian engineering and fabrication industries. Funnel manufacturing uses the frostem development. The inner sheet metal is cut from an annular sector and rolled into a funnel. Bucket and pot manufacturing uses the frostem shape. The slanted sides of a bucket are frostem lateral surfaces. Conical hoppers in grain storage facilities and cement silos are made using frostem development scaled up to meters. Megaphone and speaker horn shapes are also based on cone geometry. In the classroom, you can make cone and frostem models from cardboard by drawing the development, cutting it out, and rolling it up. This tactile exercise makes the abstract geometry concrete and memorable. Before your WAEC examination, you should be able to develop a complete cone, a frostem, and an obliquely truncated cone. To summarize cone development. For a complete cone, sector radius equals slant height, sector angle equals 360 times base radius divided by slant height, arc length equals base circumference. For a frostem, find the apex position using similar triangles. Draw an annular sector between two arcs at the full slant height and the slant height minus frostem slant height. For an obliquely truncated cone, use 12 generators. Find true lengths from the front view and true length diagram. Mark these lengths on the sector, join with a smooth curve. The base circle and top circle are always added to complete the development. Fold lines are shown as chain dash lines. Always label the development fully, cone development, scale, and all dimensions. Practice at least one complete cone development and one frostem development before your WAEC sitting.